The first question reads, a student gives a plastic strip an overall electric charge. Describe one way that the student can give the plastic strip an overall electric charge. To answer this, you can say the student can give the plastic an overall electric charge by using friction. Now, if you are wondering how this will work, the student can simply rub the plastic rod on his shirt or on a shirt. Part 2 of the question reads, Figure 1 shows a gold leaf electroscope that can be used to investigate static electricity. That is our figure there. You can see we have a metal cap, we have a metal rod, a case covering our container, okay, our insulator, and a gold leaf. So first, the electroscope has no overall charge. The gold leaf has a very small mass and can bend very easily. Okay, the student brings a negatively charged plastic strip near to the cap of the electroscope. The gold leaf bends away from the rod, which diagram shows the way the electric charge is now distributed. To answer this question, first, you have to know what is the charge of the plastic strip that was brought near to the metal cap, and that is a negatively charged plastic strip. Then now we can go to the options we have, that is option A, B, C, and D, and try to see what is the correct option. Okay, now what this question simply tests you, it's about the Coulomb's law, which states like charges repel and unlike charges attract. Now let's look at all options. Now we can eliminate option A and B since the electroscope's cap will be charged. In option A and B, there is no charge on the electroscope cap. Okay, you can see there are no charges there. Okay, now we remain with option C and D. Now we can also eliminate option D, okay, because we already know that our strip is negatively charged, but here in option D we can see that the metal cap of the gold leaf is also negatively charged, so this will be not right according to the Coulomb's law. Okay, now what we remain with is option C. That will be our answer, option C. We can move on to part B of the question, which reads, Figure 2A shows another gold leaf electroscope that has been given an overall negative charge. A student connects the metal cap of the charged electroscope to earth with a piece of wire as shown in the figure 2B. That is our figure. We already know. Now we also have to consider what the overall charge of the gold leaf electroscope is, and we know is negatively charged. Okay, now you can see our figure there, and in figure 2B you can see that there is a wire that is connected to the cap of the gold leaf electroscope. Now we are required to explain why the gold leaf has moved. As you can see in figure 2A, the angle of the gold leaf is larger than the angle of the gold leaf in figure 2b. Now we can tackle that one also. It's just simple. You can say that the gold leaf has moved since the overall negative charge on the leaf moves into earth, making the gold leaf to no longer repel. That is the simple explanation you can give. This simply means that the overall negative charge, okay, the charge in our gold leaf moves into earth through the wire. Okay, now this reduces the amount of overall negative charge. Now we already know that from Coulomb's law that like charges repel. Okay, now since the overall charge has reduced, the angle, this angle here, will also reduce. Part C of the question reads, two small objects P and Q are each given an electric charge. Figure 3 represents the electric fields around the objects P and Q. That is our figure 3. You can see object P and object Q there. Now, use the information from figure 3 to give two differences between the charge on P and the charge on Q. Looking at our figure, we can see that one, on object P, the charge is moving into, we can say it is moving into the paper, and in object Q, the charge is moving out, okay, of the paper. Now, we can use that to make our first description. From that, we can say that object Q has stronger charge than P. You can see that in our figure, there is more overall charge in object Q compared to object P. Okay, now our second explanation, we can say that charge Q, okay, charge on object Q, I mean, is opposite to charge on object P. Okay, we had already, that if you remember, I had already told you that we can see that the charge on object P is going, let's say, into the paper, while the charge on object Q is going out of the paper. The next question reads, object P and object Q are held near to each other so that their electric fields interact with each other. State the effect that the electric field of object Q has on object P. Recall that, please, when answering this, please recall that the charge on object Q is stronger, okay, and is opposite to the charge on object P. So what we can say, when the magnetic fields interact, object P will experience a force of attraction due to object Q. That is because object Q has a stronger force of attraction.